Hey guys, welcome to the worked answers for the 2021 Day 1 MCAT exam paper. Let's get into it. So question 1, find the value of 2x squared minus 3xy when x equals to negative 3 and y equals to 4. So this question is a classic substitution question. We've got this expression 2x squared minus 3xy, and wherever we see x, we're going to substitute in negative 3, and wherever we see y, we're going to substitute in 4. So we've got 2 and x is negative 3, and that's squared, minus 3 times negative 3 times 4. Okay, and we can simplify. Let's keep the 2 and we'll say negative 3 squared is 9. Minus 3 and negative 3 times 4 is 12. So we've got 18 minus 36, and not minus 36, but rather positive 36. And 18 plus 36 equals to 54. Okay, so correct solution, 18 plus 36 equals 54 gets you the achieved grade here. Just achieved here. Okay, moving on to question 1b. The equation 6 equals 2x squared minus 11x has two solutions, p and q, with p being greater than q. What is the value of p minus q? So we've got this equation, 2x squared minus 11x, and we've got, the question says we've got two solutions, p and q, and they're asking what is the value of p minus q. Well, we need to decide what p and q is, first of all, and you can see we've got a quadratic here, 11x this is. Now a quadratic is written in the form ax squared plus bx plus c, and so we can rearrange, and we're going to say 0 equals, we're going to take our 6 to the right hand side, 2x squared minus 11x, and it becomes minus 6. And so let's go ahead and factorize and solve this quadratic. So now we've got a quadratic where a is greater than 1. Okay, obviously in this case it's 2, meaning the first thing we have to do is multiply a times c, which is in this case negative 6. And it's not a, is it? It's 2. 2 times negative 6 equals 2 minus 12. And so we're looking for two numbers that multiply to minus 12 and add to the b term, which equals negative 11. Okay, and those two numbers are minus 12 and positive 1. So we're going to say 2x squared, and at this point we're going to take our b term, negative 11x, and split it up into two parts, minus 12x and positive 1x, so just positive x. And minus 6 stays the same, this all equals 0. Now we split the quadratic in half, factorize the left hand side, you've got 2x, and x minus 6 is the goes inside the brackets. And factorizing our right hand side, we can take 1 as a common factor, and inside the brackets again x minus 6. And you know you're on the right track when these two brackets are the same. Okay, so we can say 2x plus 1 is a factor, and so is x minus 6. Okay, so solving for x, 2x plus 1 equals 0, and therefore x equals minus 1 over 2. And x minus 6 equals 0. So x must equal 6. Okay, so we've got our two values for x, and indeed they are our two solutions, p and q. Now, which is p and which is q? Well, we know p is greater than q, so that means p is the larger number, so p equals 2, 6, and q is our negative half. You could also say negative 0.5. Okay, so we're not quite done. The question asks, what is the value of p minus q? So we can say p minus q equals 6 minus a half, which makes it 6 plus a half, so our final answer is 6.5. Obviously, subtracting a negative, you're going to be adding. So our final answer here is 6.5. Okay, correct difference between P and Q found. That will get you the excellence grade here. An early excellence in this paper, but a pretty manageable one. Merit correct values for X or P and Q, the same thing obviously. If you found those correct values, you get your merit, so merit is here, and you're achieved factorizing the quadratic expression, so this is our factorized form in here, gets you the achieved. Okay, moving on to question 1c now. Find the values of the numbers m and n that will make 2x plus m all squared equal 4x squared plus nx plus 9. True. So when does it make that equation true? Given that both m and n are positive numbers. Okay, so we've got this equation, 2x plus m all squared equals 2 4x squared plus nx plus 9. And they're asking us to find the values of m and n. If we look at our right hand side, which is in sort of expanded form or quadratic form, there's not really much we can do here. Let's take our left hand side and let's expand these brackets. So you could go ahead and expand. You feel comfortable with binomials. But let's write out our two sets of brackets just to help us out with our expanding. So 2x plus m all squared just means 2x plus m multiplied by itself. Our right hand side just stays the same for now. 4x squared plus nx plus 9. Okay, so we're going to expand these brackets, and what I mean by that is using the FOIL method. So you've got multiplying first, outer, inner, and last. So you've got 4x squared, and we've got 2xm plus 2xm, so 4xm is the B term. And m times m is obviously m squared. Okay, so, and that equals 4x squared plus nx plus 9. At this point we can see the 4x squareds cancel, and we're left with 4xm plus m squared equals nx plus 9. And so how are we going to find the numbers m and n? Well, if we look at, basically this is where knowledge of like terms comes in handy, especially with quadratics. Let's look at these last two, the last terms of each, on each side of the equation. M squared must equal 9. Okay, and similarly, 4xm must equal nx. Possibly the second combination, 4xm equals nx, is a little bit easier to understand because it's both of the terms have x in them. Okay, we can actually cancel out x, and so we're left with 4m equals n, and we've gone as far as we can with that particular equation. Let's look back at our m squared equals 9. Well, we can say m equals the square root of 9, and so m must equal plus or minus 3, but we remember that both m and n are positive numbers, so m can only equal positive 3. Okay, we have our value for m. Let's go ahead and substitute in to find n. So if n equals 4m, then it equals 4 times 3, and so n must equal 12. Okay, basically, the key to this question is understanding that m squared equals 9 and 4xm plus nx. 4xm equals nx. Okay, now that should get you m equals 3 and n equals 12, gets you the merit grade here. Achieved correct expansion of 2x plus m all squared should get you the achieved, so up here would get you the achieved. Okay, moving on to question 1D. Solve the equation w to the power of 4 minus 18w squared plus 81 equals 0. So we've got w4 minus 18w squared plus 81 equals 0. And how are we going to go about solving this? Well, we've already mentioned a quadratic is in the form ax squared plus bx plus c. And what have we got here? We've got a, in this case it's w to the power of 4 plus b w squared plus c. Okay, the only, apart from the w's, the only difference is that the first term is to the power of 4 and not 2, and the second term is to the power of 2 and not 1. Basically what I'm getting at is that our principles for factorizing remain the same. So we're going to look for obviously two numbers that multiply to 81 and add to minus 18. And those two numbers are minus 9 and minus 9. So we're going to say w, and not w by itself, but we're going to say w squared rather, minus 9. And we could raise that to the power of 2, but let's write out the brackets. W squared minus 9. Okay, so that we've just factorized our equation. Now we can go ahead and solve for w. So w squared minus 9 equals 0, meaning w squared equals 9. And so w must equal the opposite of squaring, which is square rooting, square root 9. And so w must equal plus or minus 3. Okay, this time we don't have to think about positives and negatives. Correct solutions, w equals 3 and w equals to negative 3, gets you the excellence grade here. You'll merit correct factorization of the equation into quadratic factors. So this is your merit. And achieved recognizing that w to the power of 4 equals w squared raised to the power of 2. So basically, within a quadratic factorization process, basically the marking schedule mentions w squared and then in brackets. And then we've got raised to the power of 2. And that equals w4, which it does. And that's basically what we were getting at over here. Okay, so our equivalent for achieved is probably this step here. So basically it's just understanding quadratics and applying your knowledge whenever there's those little variations. Anyway, moving on to question 1e. If r equals 5y minus 4x over y minus 2x, give the equation for x in terms of y and r. Okay, so we've been asked to effectively rearrange here, and they want us to make x the subject. So it's going to look like x equals whatever. Okay, so we've got this equation, r equals 5y minus 4x over y minus 2x. Okay, and we're trying to make x the subject. For our first step, we can multiply by y minus 2r on both sides. You should always look and see if there's any factorizing that can be done, especially at the fraction here, but there isn't. So let's multiply it by y minus 2x on both sides. So we've got r and then y minus 2x, and it equals simply 5y minus 4x because the y minus 2x cancels out. Okay, so we've got rid of that fraction. We've got just a single line of basically working, and you'll notice that we have x's appearing twice, and if we want x to be by itself, then we're going to have to basically do something about that. We're going to have to factorize at some point to get x by itself. Okay, in the meantime, we can expand these brackets. So again, multiplying what's outside the brackets by what's inside the brackets. And so we're going to say ry minus 2 rx equals, and our right side remains unchanged, 5y minus 4x. Okay, in order to factor out x, we have to bring our x's to one side. So we're going to bring our 4x to the right hand side. We're going to say positive 4x minus 2 Rx, and at the same time we'll bring our Ry to the right hand side, so it becomes 5y minus Ry. We can take x as a common factor here. We've got x, and inside the brackets 4 minus 2r, and that equals 5y minus ry. Okay, we're trying to get x by itself. We're going to say x equals, and we're going to multiply by 4 minus 2r on both sides. Okay, and with that, we have successfully rearranged. We've given our equation in terms of for x in terms of y and r. And so correct rearrangement here gets you the excellence grade. Okay, your merit. You've multiplied the left-hand side by y minus 2x and left the numerator on the right-hand side, and consistently collecting terms involving x and terms not involving x on different sides of the equation. So your merit is this point here, and achieved was just that first thing, multiplying the left-hand side by y minus 2x. So this step here gets you the achieved. Okay, moving on to question 2. So question 2a, given that the perimeter of the shape shown below is 34 centimeters, find the value of x. So we've got these dimensions here, x plus 2, x, 2x minus 1, and x plus 3. And it says the perimeter equals 34. Let's first remember what the perimeter of a shape is. Obviously, it is the sum of the sides of the shape. Okay, so we're going to basically insert our side lengths in now. Our perimeter is 34. That's what we've been given. And so working from the top clockwise, we can say x plus 2 plus x plus 2x minus 1 plus x plus 3. Okay, so we've established our equation here. At this point we can collect like terms. So basically we're going to be adding terms with just a single, with just x's in them rather. So x, 2x, and again just that single x. And we're going to be adding terms where there are just single digits, so 2, -1, and +3. 34 remains unchanged for now. Looking at our x's, we've got 1, 2, plus 2 is 4, plus 1 is 5. So it is 5x. And our green, our single digits, 2 minus 1 is 1, plus 3 is 4. So that's +4. We can take 4 to the left-hand side. It becomes -4, so it's just 30 equals 5x. And we know we can solve for x here. X equals, dividing by 30 on both sides, 30 over 5, or x equals 6. Okay, and this forming and solving the linear equation x equals 6 gets you the achieved grade here. Okay, moving on to question 2b. We've been asked to solve the inequality 3x plus 2 multiplied by 2x minus 1 is less than or equal to 6x plus 1 times x minus 3. Okay, so a long-winded inequality here. Let's first just write out our inequality. 3x plus 2, 2x minus 1 is less than or equal to 6x plus 1 times x minus 3. So we haven't really got much to do here apart from expanding our brackets, so let's go ahead and do that. Looking at our left hand side, we've got 3x times 2x is 6x squared, minus 3x plus 4x is positive x, and 2 times negative 1 is negative 2. And this is less than or equal to 6x squared minus 18x plus x, so minus 17x minus 3. Straight away we can cancel the 6x squareds. Let's bring our, so we want to bring our x's to one side. Let's take the minus 17x to the left hand side, and we're going to say x plus 17x is 18x, and this is less than or equal to minus 3 plus 2. We take our plus 2 to the right hand side, so that equals just minus 1. And so solving for x, x is less than or equal to minus 1 over 18. Okay, correct inequality found gets you the merit here. Achieved, expand either quadratic expression. So just our first step, we expanded both at once. So this step here gets you the achieved. Okay, question 2c now. The perimeter of rectangle A is 46 centimeters, and the perimeter of rectangle B is 32 centimeters in the diagram below. So we've got this diagram. Find the length and width of rectangles A and B. Okay, so we've got some dimensions. Rectangle A, you've got a length of 7p and a base of 3q, and B is 2q and 5p. And once again, the question is asking us to find the length and width of rectangles A and B. And so we can assume that's in like integers, not using variables or anything. So we have to first use this information for the perimeters. Perimeter of rectangle A is 46. Perimeter of rectangle B is 32. So we can say perimeter is, let's write it again, perimeter is the sum of the sides. And so if we look at A, we can say, and remembering that we're dealing with rectangles, so we can actually say this is 7p over here and 3q along the top, and similarly 2q and 5p for B. Okay, A, we've got 14p, because 7 plus 7 is 14, plus 6q, and the perimeter is equals 46. Okay, rectangle B, you've got 10p plus 4q, and its perimeter is 32. And so the only way to make progress here is by solving these equations simultaneously. And you'll hopefully know there's two ways of doing simultaneous equations. You can do the elimination method or the substitution method. Substitution here would be slightly difficult, so let's use the elimination method. We want either P or Q to have the same coefficient for both equations. Let's take Q to 12 here. And so we're going to multiply our equations. We're going to multiply A by 2 and B by 3. So this looks like for A, we've got 28p now, plus 12q, and that equals 46 times 2 is 92. And for equation B, 10 times 3 is 30p plus 12q, and that equals, apologies, just plus 12q, and that equals 32 times 3, which is 96. At this point in our remembering we're using the elimination method, we've got 12q for both equations. They're both positive, which means we are going to subtract our two equations. And so working in columns, so we've got our p's, we've got our q's, and our integers. We can say 28p minus 30p is minus 2p. The q's cancel out. 12q minus 12q is 0. And so that equals 92 minus 96, which is minus 4. If minus 2p equals minus 4, then dividing by 2 on both sides, p equals to 2. So we've got our value for p. We need to find the value for q, and so we can use any of our equations to find a q. Q. And so let's use our 14p plus 6q equals 46 equation, and let's say 6q, we'll make q the subject, equals 46, and we'll take the 14 to the right hand side, so it becomes minus 14p. Okay, so 6q equals 46 minus 14 times 2. It equals 46 minus 28. Now 46, let's even write it in. 46 minus 28, and that is 18. So 6q equals 18, and therefore q equals, dividing by 6 on both sides, equals 3. Okay, how much room have we got left? Okay, so we've got p equals 2 and q equals 3. Now the question actually asks us to find the length and width of rectangles A and B. Now the length and width of A is 7p and 3q respectively. So let's say rectangle A is 7p by 3q. We can substitute our values in. So it becomes 7 times 2 is 14 by 9. Rectangle B, the length was, let's say it was 5q, and the width was 2q. So 5q by 2q. They're not both q's, are they? Which was p? 5p times 2q. 5p times 2q. Okay, so 5 times 2 is 10 by 2 times 3, which is 6. And with that, guys, correct dimensions of both rectangles found gets you the excellence here. Merit correctly combines the equations into one variable, so that is, if you were using the substitution method, you'd probably get your merit slightly earlier, but we get our merit at this point here. We use the elimination method, obviously. Achieved forms both equations for perimeters. So that was basically our first thing we did, so achieved here. Okay, moving on to question 2D. Solve the equation x plus 2 over 3 minus 2x minus 1 over 5 equals to 1. Okay, so x plus 2 over 3 minus 2x minus 1 over 5, and that equals 1. We can't factorize, and so we're going to go ahead and cross multiply in this case. So we're going to multiply diagonally, and we're also going to multiply our denominators. So this looks like 5, and then x plus 2. We'll keep it in a factorized form for now, and we can also keep it as separated fractions as well, just to show the whole process. The denominator is 3 times 5, which is 15, and minus 3 to x minus 1. Again, that's over 15, and that all equals to 1. Now we can expand our brackets. We've got 5x plus 10. At the same time, we'll combine into a single fraction now. It's minus 6x. We can even chuck another set of brackets like that. Minus 6x, and this is actually positive 3. And this is all over, knowing our fraction rules, we don't do any, 15 minus 15 or anything. We just say this is all over 15. Equals 1. On the numerator, let's collect like terms. So we've got 5x and minus 6x, and we've got 10 and 3. We've got basically minus x and plus 13, I believe. And this equals, we'll take our 15 to the right-hand side by multiplying by 15 on both sides. 1 times 15 is 15. And so minus x equals 15 minus 13, so 2. If minus x equals 2, then x must equal minus 2. Okay, correct solution, x equals to minus 2, gets you a merit here. Achieved correct correct arrangement for both numerator and denominator does not need to be expanded or simplified. So I'd say this step here gets you the achieved. Okay, question 3E now. 2E that is. A rug 3 meters long and 2 meters wide lies in the center of a rectangular room, leaving a border X meters wide between each edge of the rug and wall. So at every point here, this is basically a distance of X. The area of the whole room is double the area of the rug. Okay, that's an important point. The question asks us to find the width, X meters, of the border. So basically solve for X here. Let's look at our area statement, remembering that the area of a four-sided shape is base times height, and it says the area of the whole room, so we can say area room equals the area of the whole room is double the area of the rug. So we can say area room equals 2 times the area of the rug, and because if we multiplied the area of the rug by 2, that would satisfy, basically it would equal the area of the room. Okay, area rug. And so we can substitute in some lengths here, remembering base times height. Area of the room is, now we haven't actually found our base and our height, or our length and our width. So for the room, this is going to be our width. And what is that distance? Well, this is 2, and this is X, we know. This is also X. So we can say the width, or the height of the whole room, is 2 plus 2x here. Now the length, it is this whole length, and this is 3 along here. Once again, you've got x and x. Therefore, the length of the whole room is 3 plus 2x. Okay, and that equals, looking at the area of the rug, 3 times 2, so basically 6. 2 times 6, but we could even, just to save ourselves a step of working, rub that out and say 12 straight away. Okay, so we've established this equation here. Let's expand our brackets. We've got 2 times 3, 6, plus 4x plus 6x is positive 10x, and then plus 4x squared, and that all equals to 12. We want to put it in quadratic form, so ax squared plus bx plus c. Take everything to one side. Let's take the 12 to the left-hand side. We're going to say 4x squared plus 10x, and then 6 minus 12 is minus 6. And that equals to 0. Always look for a common factor before doing anything else. We can take a common factor of 2 here, and then just make it easier on ourselves when factorizing this quadratic. So we've got 2x squared plus 5x minus 3 equals 0. Obviously our 2 just cancels. And so let's multiply a by c. So 2 times minus 3 equals minus 6. And so we're looking for two numbers that multiply 2 minus 6 and add to the b term, which is 5. And those two numbers are plus 6x minus x, or minus 1. So we can say 2x squared, we split our b term into plus 6x minus x minus 3, and it equals to 0. Cutting our quadratic in half, factorising the left hand side, 2x is a common factor, and x plus 3. And on our right hand side, minus 1 and x plus 3, and it's already been said, but if these two sets of brackets are the same, then you know you're on the right track here. So 2x minus 1 and x plus 3 equals to 0. And let's not take the time to write out each individual equation. We can go ahead and say x equals 1 over 2 or negative 3, but remembering that in this case, we are working within the constraints of the question, within the context. And if x is a side length, which it is, all around our diagram, basically you can't have x equals minus 3 as an answer, because you can't have a negative length. And so, and you have to write a statement for this as well. Because x can't be negative, we'd say x does not equal minus 3, and only answer is x equals 1 over 2, or you could say 0.5. Okay, and completing this, correct positive solution found for the question with evidence of the correct negative value disregarded. So that's this statement here, x can't be negative. Gets you the excellence here. Merit simplification to a quadratic equation. So simplification to a quadratic equation. So probably this step here gets you a merit. It's a fairly easy merit as well. Your achieved is forming the correct expression for lengths of both walls in terms of x. So our first step would get you the achieved. Okay, moving on to question 3. What is the area of a square with sides of length 3x plus 5 centimeters? Give your answer in terms of x and in the form ax squared plus bx plus c. So we've got the square, we can even draw it. It's got lengths of 3x plus 5, and it's a square, so every side is length 3x plus 5. It's asking us to find the area. Now remembering that area is base times height, and so substituting this in, it's going to be 3x plus 5, and you could say all squared like this, and let's even do that, or you could say 3x plus 5 times 3x plus 5, and this equals, and it's not good enough to stop here, remembering that the question asks us to give our answer in the form ax squared plus bx plus c. So we actually have to expand these brackets, so not 3 but 9x squared. And the b term is actually 2ab if you look at it in binomial form, so 30x plus 30x, and 5 times 5 is positive 25. Okay, 9x squared plus 30x plus 25. Expanding and simplifying the quadratic gets you the achieved here. Okay, moving on to question 3b. Solve the equation 2 to the power of x times 2 to the power of 3x minus 8 equals 16. Right, so 2 to the power of x times 2 to the power of 3x minus 8, that equals 16. We have to employ our basically our base rules, our indices rules, whatever you want to call it. Looking at our left-hand side, if we're multiplying two numbers of the same base, that means we add the powers which they're raised to. So it's going to be 2 to the power of x plus 3x minus 8, so 4x minus 8. And looking at our right-hand side, we could write 16, but it's also, so basically this is a classic MCAT question. A similar question pops up every year. It's important to know your powers of numbers. So powers of 2, 3, 4, 5. And so we've got, we're going to list the powers of 2 here. Okay, 2 to the power of 1 is 2. We've got 4, 8, and 2 to the power of 4 is 16. And we're actually going to, instead of writing 16 in our equation, we're going to use 2 to the power of 4. Okay? And so, at this point, we've got two numbers that equal each other. They have the same base, which means we can cancel the bases and say that the powers that they're raised to must also equal each other. Okay, so 4x, it's a pretty simple solving from here on out. 4x equals 4 plus 8, which is 12. X equals, divide by 4 on both sides, x equals 2, 3 here. Okay, so correct value of x, x equals 3, gets you a merit. Achieved simplification of the powers of 2 on the left-hand side. So this would get you an achieved. Okay, moving on to question 3c. We've been asked to solve the equation 2 over x minus 3 minus 2 over x plus 1 equals 3 over x plus 5. Okay, let's just write out our equation first of all. Equals 3 over x plus 5. And there's possibly a number of ways of solving this. Let's just work with our left-hand side, and basically we're just going to cross multiply again here. So we're going to cross multiply, and we're going to multiply our denominators as well. So we've got 2 and x plus 1. Let's go ahead and combine it into one fraction first of all. At this stage, let's not drag it out. It's all over x minus 3 and x plus 1. Okay, our right hand side remains the same, 3 over x plus 5. We could put brackets in here, and in fact it's proper practice to put brackets here as well. Okay, expanding our brackets, we've got 2x plus 2 minus 2x, and then minus 2 times minus 3 is positive 6, and this is all over x minus 3 and x plus 1, and we could actually expand our denominator, and we probably should have. That's alright. 3 over x plus 5. Okay, let's collect the like terms on the numerator on our left hand side. 2x cancels, and we've got 2 plus 6 is 8. So it's going to be 8 over, and we are going to expand our denominator here. X squared plus x minus 3x is minus 2x. Minus 3 equals 3 over x plus 5. And how much room have we got here? Okay. We've got these two fractions that equal each other. So another thing we can do is cross multiply again. Not multiplying the denominators, but simply cross multiplying. So we've got 8 and x plus 5 on the left hand side, and we've got 3 x squared minus 2 x minus 3 on the right hand side. And we can see a quadratic starting to form here. Let's expand our brackets. 8x plus 40 equals 3x squared minus 6x minus 9. I hope this is making sense. And so collecting, well, not collecting like terms, bringing everything to one side and then collecting like terms. Let's bring the 8x plus 40 to the right hand side, purely to keep 3x squared as being positive. Having the x squared term as positive is just something I prefer, and it's probably easier to work with. We've got 0 equals 3x squared, and then minus 6x minus 8x is minus 14x. Minus 9 minus 40 is minus 49. Okay, we're running out of room here. We could we have to factorize this quadratic. We could go ahead and do our a times c, split the b term, split the whole quadratic in half. Let's just take a moment to look at our numbers though. Obviously the factorized form of a quadratic is x plus or minus a number, close bracket, open bracket, x plus or minus a number. Okay. Let's look at our a term, so 3. What two numbers multiply to 3? Okay, it's a prime number, so 1 and 3. And we're in the MCAT, there's no calculators. We're not going to be working with, multiplying fractions to get to 3. So we can confidently say that we've got a 3x in there. Our second pair of brackets, obviously this is just 1x, but the 1 is, we don't write the 1. And looking at our c term now, factors of 49, 149, and I believe 7. So 7 times 7 is 49. It's a square number. And so again, with confidence, we can say that 7 is going to make up our two numbers. Now, is it Where's the positive? Where's the negative? Well, the c term is negative, meaning it's going to be a positive and a negative. And so we can go ahead and say that 3x plus 7 and x minus 7. And that, believe it or not, is the correct factorization. If you had some time at the end of the test, you'd probably go back and prove that this is the case. But we were running out of room slightly. Anyway, this all equals 0. We have to solve for x. So 3x plus 7 equals 0, meaning x equals minus 7 over 3, and x minus 7 equals 0, meaning x equals 7. Are there any constraints on whether x has to be, positive or no? It's a straightforward question. There's no background or no context. So these two values, 4x minus 7 over 3 and 7, gets you the excellence grade here. You'll merit correctly rearranging equation to remove the denominator. So this step here maybe gets you the merit. Achieved correct arrangement of numerator and denominator on the left hand side. And it says in brackets except the unsimplified expression. So we can say this step here gets you the achieved. Okay, moving on to question 3D. We've been asked to simplify as far as possible this fraction, 2x squared minus 3x minus 14 over 2x squared minus 8. So we've got 2x squared minus 3x minus 14 over 2x squared minus 8. And you look at this fraction and instantly you think factorizing. And so that's what we're going to do here. Looking at the numerator, we multiply a by c, so a times c, so 2 times negative 14 is negative 28. So we're looking for two numbers that multiply to negative 28. And my mistake, where are we? Two numbers that multiply to negative 28 and add to the b term, which is minus 3. This is all for the numerator. Those two numbers are minus 4 and positive 7. No, it's positive 4 and minus 7 rather, just thinking about that negative 3 in there. So we can say for the numerator, 2x squared positive 4x minus 7x minus 14. It's all over, and we can also factorize our denominator as well. We can take a common factor of 2. We can say x squared minus 4. Okay, on the numerator, let's continue with our factorization. Let's split the quadratic in half, and we'll factorize the left-hand side, 2x, and x plus 2. And for the right-hand side, minus 7, and then x plus 2. Okay. Okay, and this is all over 2. And you might be inclined to forget about the denominator, but actually x squared minus 4 we can further factorize this. So this is difference between squares. X squared is a square number, as is 4, and the factorized form in this case is x plus 2, x minus 2. Okay, difference between squares. It is useful if you can recognize this. So, for example, you might have x squared minus any square number, I don't know, 64, 81, 49. This one would be x plus 8 and x minus 8. Okay, but we've got x plus 2 and x minus 2. Okay, now continuing with our numerator, 2x minus 7. And x plus 2. And that's all over 2x plus 2 and x minus 2. And at this point, we can cancel x plus 2 on both the numerator and denominator. And so we're left with 2x minus 7 and 2, and you could expand these brackets once again, 2x minus 4. And so this fraction, guys, 2x minus 7 over 2x minus 4 gets you the merit here. Achieved is numerator or denominator fully factorized. So numerator or denominator, where did we... Our numerator was this step here. Our denominator was this step here. So let's say this is our achieved. Numerator or denominator achieved. We could even write achieved here as well. Okay, moving on to question 3e, the last question of this paper. Ben has been painting some straight lines on the field for his rugby team to do some training exercises. The total length of all the painted lines shown in the diagram below is 20 meters. This is our diagram. If the shaded area is 14 meters squared, so area equals 14, find the values of x. Okay, so the first thing we can do is draw in some more length. So this length is x, so is this length, and this is y. And what are they asking us here? Let's think in terms of total length of all the painted lines. So this piece of information here, the total length of all the painted lines is 20 meters. So let's add up our total lengths. For x, we've got 3 x's, and our y's, we've got 2y. Okay, and that equals 20. And now let's look at our area statement. If the shaded area is 14, okay, we can actually establish an equation for the area of this shape. Area is base times height. The base is x, and the height is y, and that equals 14. Okay, so we've got two equations, 3x plus 2y equals 20, and xy equals 14. And we're trying to find x. So we can do this by solving simultaneously. It's a little bit different in that we've got this sort of odd xy equals 14 equation. but we use the same principles. Let's use substitution. We're going to say instead of xy equals 14, we're going to say y equals 14 over x. Okay, so we've isolated one variable. And so we're going to say 3x plus 2, and instead of y, we write, we substitute in our equation for y, 2 times 14 over x. And that equals 20. Okay, we can expand our brackets. We've got 3x plus 2 times 14 is 28 over x, and that equals 20. And what to do now? Well, at this point, we can cross multiply. We draw an imaginary 1 in the denominator of 3x just to help us, and we're going to cross multiply. Okay. And so we've got 3x times x is 3x squared plus 28 times 1, just 28, and that's all over x equals 20. Okay, we can say 3x squared plus 28, and we bring our x to the right hand side. If we're dividing by x on the left, we multiply by x on the right, so it equals 20x. And now we can see a quadratic here, so 3x squared, bringing everything to one side, minus 20x plus 28, and that equals 0. Okay, we multiply a and c. So it is, let's just do it over here, 3 times 28. Now that is a difficult calculation. 3 times 20 is 60, 3 times 8 is 24, so it is 84. And so we're looking for two numbers that multiply to 84 and add to the b term, which is minus 20. And those two numbers are minus 6 and minus 14. You'll find that 6 times 14 equals 84, and you can sort of tell that in here because 3 is half of 6, and 28 is double 14. Okay, so we've got 3x squared minus 6x minus 14x plus 28, and that equals 0. So, splitting the quadratic in half, we factorize the left-hand side. 3x and x minus 2 is a factor, then minus 14 and x minus 2 all equals to 0. So 3x minus 14 becomes a factor, and x minus 2 is our second factor. All equals to 0, so we can straight away say x equals positive 14 over 3 or positive 2. Okay. Now, I was about to say, what are our constraints on x? Because we are working to a context in this situation, but actually both of our answers are positive. So, both values of x, 14 over 3 and 2, gets you the excellence here. Your merit is forming an equation in one variable. So this sort of simultaneous equations work. Up here, merit, and achieved forms the equation 3x plus 2y equals 20. So even just forming that equation gets you the achieved here. Okay, and with that, we have completed our paper. Thank you all for watching. As ever, any questions, comments, chuck them in the comments section below. I hope you enjoyed, and I will see you next time. Cheers.